Good evening, everybody, and welcome to week 2 of our National Safety Month live streams. This evening we have Peter Ball from CASA who will be presenting on error management in maintenance. And I'd like to take the opportunity to thank CASA, who is the sponsor for our week 2 initiatives, but also to Peter for joining us this evening. Before I introduce Peter, I'd just like to thank our members who have participated in National Safety Month. In the first week, we've had over 400 total submissions to our multiple quizzes and content that we've had available online. So I'd like to thank everyone for getting involved. Please continue to stay involved throughout the month of October and share the information amongst different people and get in those draws to win in those different quizzes. To enter our live stream competition this week, please make sure you go to our website. If you're watching tonight on Facebook or YouTube, if you go to the RAL's website and follow through to tonight's live stream, you will see the question submission from tonight's presentation. If you would like to ask Peter a question, you can also do so from that page, and we will have any questions following his presentation. Before we get going, I'd just like to announce the winner of last week's Week 1 live stream, which was a 12-month Oz Runways VFR premium subscription and a 12-month RAL's membership. And the winner of our Week 1 was Kevin Ormond. So congratulations, Kevin. We'll reach out to you in the next few days to ensure that we can pass on those prizes from our Week 1 live stream. Our prizes this week, for submitting your entry to the draw, we will have a 12-month RAL's membership, and all applications also go in the draw to win our Open Safety Prize Pack, which is available for members and non-members. And for our maintainers that watch and submit this week, you'll also get an extra entry into the draw to win our Maintenance Matters Prize Pack. The main prize there being the Lamy Flyaway Toolkit, valued at over $3,000 that I've got here next to me, which is a pretty fantastic prize to have available. Finally, I'd like to take the opportunity to thank our National Safety Month sponsors. There they are on the screen there. We couldn't have done it without our sponsors who've put together up to $10,000 worth of prizes across the month of October. So thank you for everyone for getting involved, and thank you to our sponsors. So on that note, I'd like to welcome Peter Ball to our presentation. Good evening, Peter, and thanks for joining.
Yeah, good evening, Cody. Thank you very much to RAOZ and especially the RAOZ safety team for the opportunity to participate. And yeah, we're very appreciative of that opportunity.
And we thank CASA for the support and the sponsorship, but also for you for joining us this evening for your presentation. So on that note, I will leave you to it.
All right. Is the presentation up? I can't see it on the screen just yet. Do I need to? Yeah, there, Cody. I can't see the presentation on the screen. Is it active?
Should be up and active now. Yeah.
Okay. All right. Okay. So the objective of this evening is for us to discuss one particular aspect of human factors, and that being the one that comes under the error management banner. So before I get into that, I'll just give you a quick little introduction to myself. I'm an aviation safety advisor with CASA, been with CASA since 2008. I'm based in Darwin. I did grow up in an aviation family from a very young age, and was exposed to aviation, all aspects of that in a general aviation sense. Decided to make my career in aviation maintenance, and was lucky enough to get an apprenticeship and realised an airframe and engine licence, which is what we currently call a B1 with exclusions, and I obtained that in 1987. Started in GA, worked my way up to large turboprop aircraft and regional jets. And one of the aspects I've dedicated my time in CASA to is providing professional development opportunities for all, and especially given my maintenance background, trying to provide that to the engineering fraternity in Australia. I guess one of the things to think about here is that we're all humans and we all make errors, no matter what we like to think about ourselves. We are error prone. And these topics we're going to talk about tonight, they're not just limited to aviation or maintenance. Because as humans in every endeavour, in every industry throughout the world, error management is something that goes on in all of those industries and every organisation and club and institution. So it's not just limited to that. What I will say also is that as good at making errors as humans are, we are pretty good at detecting them before they become a danger to ourselves or others. So that's one aspect of just, I guess, looking at things across the board. And now we're going to have a bit of a dig right into the error management aspect of things. What I might just say prior to that is this is a current topic, the major topic in our current engineering seminars that we're running all across Australia. And it's gathering quite a bit of interest and enthusiasm. A lot of people get very involved in the face-to-face presentations that we do. So it's been very positive to date. As you can see there, I'll read through some of these just in case you can't see them. But maintenance accidents and maintenance errors, there's varying estimates on the proportion of those that are related to accidents with those errors. And according to some authorities, maintenance errors may be playing an increasing role in causing accidents. So we'll talk a bit about why that might be. We'll start pretty easily. What is an error? You ask any three people what they think it is, and you might get some different answers. But this is the definition that's stated in the material that I've pulled a lot of this information from, and it is actions and inactions that lead to a deviation from intentions or expectations. That is, things don't go as planned. And these you can relate a lot of this to flying activity, as I'm sure many of you are pilots as well here tuning in tonight. So digging down into the human error aspects of things, the definition of that one is when during those occasions where a planned sequence of mental or physical activity fails to achieve the intended outcome. So you had a plan, you wanted to achieve a certain thing, and that didn't go to plan. It can be for any one of a range of issues, but as I said, we're going to talk about error tonight. It is a natural threat because it's in all of us to have the ability to make errors. And as we'll see, there's various reasons that those errors can occur. We need to understand the risk factors of those human errors occurring and try to reduce the frequency of those. We're never going to eliminate it completely. So some people say, well, will we even bother? But we do need to try and manage those errors and look at the risk factors that we can anticipate in humans making. We also need to try and limit those effects, and we'll talk about some ways that we might be able to go about that as well. So there's a couple of different types of errors. There's probably quite a few more than this, but we'll just talk about these two tonight. What is an error of omission and an error of commission? So omission is when you fail to perform a necessary action, whether that's a step or a whole maintenance action that's required, that's made up of some steps. It could be failure to carry out a leak check after an engine run, things like that, or to do a second check of flight controls. An error of commission is an action performed that should not have been. You might do the right job, but on the wrong side of the aeroplane, that sort of thing. And these things happen all the time. I've seen it, especially in multi-engine aircraft. People do, the right mag on the left engine and things like that instead of the left mag on the right engine. We are only human after all, and we have limits of what we can take in. So it comes back to communication as well, just trying to ascertain, the correct job that needs to happen and the location for that job. So when an error occurs, obviously there might be a failure to detect that error. So we have a couple of different types of failures in that mode. If something, the job is done on the wrong side or the job is done incorrectly, we can have active failures and we can have latent failures. So active failures are things that should be picked up really quickly, whether it's through a leak check, or it could be like cross controls in a flight control system. That should be picked up at the initial inspection or the duplicate inspection, as the case may be. But then we've got a couple of other checks and balances there for the pilot, the next person to flight doing a daily inspection, and then also their full, free and correct checks of flight controls prior to entering the runway. There wasn't a very well-known incident quite a few years ago now where a Cessna 300 series aircraft actually got airborne in Adelaide with the ailerons reversed. Somehow the pilot actually managed to get that back on the ground. But as you'd imagine, there was a lot of steps there that were defeated to allow that aircraft to actually become airborne. So not a great outcome. The other type of failure I'm talking about here tonight is the latent one, and that's where an error has occurred, and it could be an incorrect torque on a wing strut, or an incorrectly assembled flight control, things like that. Things that can actually sit there for quite a long period of time and not actually show its head until a certain set of events line up. And that could be things like, over time, you can get some stress fatigue, bolts coming loose in that incorrectly assembled joint, flight control not correctly assembled. There might be a certain flight load that needs to occur to make that flight control jam or something along those lines. So those latent failures, they could sit there for a week, a month, or even years before they showed their true hazard and could make something really, really bad happen. So, an unintended consequence is what I'm trying to say. So just keep that in the back of your mind there, those two different types of failures when we start talking about error detection, when we're trying to make sure that any errors that are made don't actually get out onto the flight line before a flight occurs. As usual, I get in front of my slides here, so apologies for that. I've already talked about active failures and cross-rigging of aileron controls and latent failures that can remain dormant for quite a long period of time until they could contribute to an accident. As we know, accidents generally don't happen because of a single failure in some sort of procedure or action. You usually need a couple of things to line up to cause that. This is something we call the Swiss cheese model. It was come about by Professor James Reason. It's an accident causation model. I'm sure many of you have already seen this, but basically it's just talking about oops, I'm on the wrong bit there. I can't see it. So these slices of Swiss cheese represent defenses to stop an event or a hazard getting out onto the flight line, essentially. So we have defenses like training and inspections and procedures and things like that, leak checks, whatever it is, to try and identify an issue prior to it becoming a drama in the aviation sense when you take the aircraft up into the air. So as it says there, errors have consequences and causes. So we're going to have a look at some of those causes and how we might be able to reduce them. And identifying the human error is a starting point. And I think it's really important while we're talking about human factors to acknowledge our frailty, I suppose, as human beings. There's no perfect aeroplanes, there's no perfect systems in aircraft, and there's no perfect people to maintain them or fly them. We all make errors, and certain sets of circumstances can make those errors more likely to occur. So we need to look at reducing them, and what we do is we put in error mitigation, error capture, and error tolerance, and we'll talk about some reasons as to, some ways of doing that as well. So this is just a bit more information, a bit more in depth, I suppose. And we're going to use these slices of cheese with the holes in them, and the holes represent where the initiating event or the hazard can circumvent things we've put in place, whether it's training or experience or knowledge or leak checks or procedures, all these sorts of things. Humans in general and Australians, we're pretty good at finding a shortcut or a quicker way to do things. So, sometimes people will try and get things done a bit quicker or easier or cheaper, and they'll, sometimes these hazards can find their way through these protections. So these are what I was talking about before, those error capture mechanisms. So some of these defences are making sure you're fit for work before you go and do the job. You really need to be have a low fatigue level. Probably not a good idea to do aircraft maintenance on a Friday afternoon after you've had a big week at work. You want to be in good condition, not sick, not have had a big night out with your mates the night before, all that sort of thing. And basically be fit for work. Now, everyone's got procedures when it comes to performing any sort of maintenance work on an aircraft. And you need to have those procedures, make sure that the data you're using is current from the manufacturer of the aircraft and the procedures are the correct ones for the aircraft, and also tooling as well. That's something I've seen many cases of in my career where people have used not quite the correct tool. It can result in the job being substandard. You can result in injuries to the people doing it and also damage to the aircraft if things go really wrong. Training and authorization to do the level of maintenance that is happening. The training and authorization requirements, that's not an accident. We want to make sure that people are competent and capable to do those tasks prior to undertaking them. If the task and inspection happens and there's an untoward incident or accident because those the holes in the Swiss cheese line up and the error makes it through to the flight line, sometimes that can result in an unintended outcome or a very poor outcome, and we don't want to see that. But sometimes these things get caught before they result in a very poor outcome. That's a perfect opportunity, and the last slice of cheese there on the right represents a reporting culture. Usually when there's a very poor outcome, it's pretty well impossible to avoid an investigation or report. But if something happens and it is caught, then don't say things like, no harm, no foul, let's go, get on with things. That's a free lesson. That's an opportunity for you to share that information with your colleagues and everyone doing the activity that you like. And that can only come about by reporting. And if there's enough of those reports that can identify, where there might be a lack of training, lack of procedures, lack of data, lack of awareness of certain requirements prior to undertaking that work. So just think about those free lessons, and make sure that you look after your fellow aviators and share that information. As a aviation technician, you need to have a little bit of humble about you. Acknowledge that you will make mistakes. Acknowledge that those mistakes can help other people learn and not make those same mistakes. You do need a level of confidence. There's no doubt about that to undertake any form of this type of activity. But don't have too much confidence. And I think also just that little shred of self-doubt is not unhealthy either. I quite often relate the story of once I gained an engineering license and started certifying for my own work, having finished my apprenticeship. On quite a number of occasions, something I couldn't get something out of my head, and I would drive back out to the airport, open the cowl and check and make sure whatever it is that I suspected I hadn't done was actually completed. So that's what I mean about having that little bit of self-doubt. And, obviously there's some aspects of tasks that we need to get people to come and do a second check on, but don't ever be too have too big an ego, I suppose, to ask someone to come and second check your work, even if it's not a requirement for that particular task. The outcomes can be fairly severe. I can remember any number of occasions where I probably wasn't feeling the best on the day, or it was a long shift, or it was a night shift. And even though it might not have been a flight control, I'd get someone to come and just say, oh, look, just do a gross error check on this for me. Does it look right? Does it feel right? Have I left any rags in? Is it lock wide the correct way? All those sorts of things. And, sometimes I'd use apprentices or completely unqualified people just as a second check, a second set of eyes, just to give me that confidence that, I haven't made a blunder based on my, maybe compromised fitness for work, because sometimes that just happens due to the length of shift, and you can have some accumulative fatigue as well, which is why I talked about probably Friday afternoon is not a great time to be doing maintenance on your aircraft. So we got so we looked at some of those defences to try and stop those poor outcomes. Now we'll look at some of what these holes in the Swiss cheese might actually be. We've talked about the fatigue aspect of things, and there's various aspects to that. Really the only antidote to fatigue is sleep. So essentially, from the minute we wake up in the morning, we're already starting to fatigue, and then that just ramps up through the day. And if we're into the night, that can really affect our capability, and then obviously it can be cumulative over any number of days. Stress, that's a really big one. We've all got a lot going on in our lives. We get all sorts of stresses from home and work, so that can also add up to causing issues for people looking for workarounds to get out earlier, and being distracted and interruptions, and we'll talk about those aspects soon as well. Alcohol and other drugs, these are things, whether it's cold and flu tablets, Panadol, prescription medications. Many people like to have a drink with their dinner the night before, but just be aware that any alcohol in the system can certainly lead to a lack of attention or a lack of adherence to procedures, and render you potentially unfit to do that work. So when procedures data are not followed, or they're out of date, or the tooling is out of calibration, that can lead to things like under torque or over torque of fasteners that can cause them to fail or come loose over time, wrong pressures, wrong cable tensions and things like that for calibration. But it's a real danger when you don't follow the correct procedure, or if that procedure is out of date, because procedures are updated by manufacturers in an ongoing manner. So if you've got a cheat sheet in your toolbox there to do a certain job, it could be 1, 2, 5, 10 years old. It may well have been superseded. So make sure you're using the up-to-date data. If your training and licensing is not current or incomplete, or the task that you need to do or want to do is not part of your privilege, these are some of the holes that can open up in those defences to stop errors creeping in and causing a failure, and then thereby an incident. So make sure that you are actually, do you have that privilege to do that job? Not just that you think you do, or that someone said you can. You really need to ascertain that you do actually have that privilege to undertake that particular task. So if the error is not avoided and is not captured, then if one of those aspects is deteriorated, and the event, the initiating event or hazard, gets through all those mitigation and capture aspects of their procedures, then a poor outcome could occur. So that's when you can't avoid a report or an investigation if it's really obvious that something an unintended consequence has occurred. But as I said, a near miss or something that hasn't resulted in that sort of mandatory reporting, the report really still needs to be made. As I said, there's learning points in there, not only for your own, but for not only for yourself, but for everyone else. So eat a bit of humble pie, leave your ego out of it. and have that, I guess, maturity to make sure that you go to the extent of making sure that people understand how you got caught out and it could happen to them. So we'll move on to error-producing conditions. You're probably all going to identify with some of these aspects. As I mentioned earlier, we're all human, so these are pretty common things. Time pressure, problems with equipment tooling, lack of spares generally can cause some issues to creep in there, reusing items that probably shouldn't be, incorrect tools, wrong equipment. This is something that a lot of people suffer from in every industry, is insufficient training and lack of experience. Poor coordination within the maintenance activity itself. Certain steps need to happen in order, and sometimes they get out of order, or there's a couple of people doing jobs and they're slowing each other up and causing poor coordination. Fatigue is a big one. We keep mentioning it, but that has a huge effect on people's ability to perform the jobs correctly. Deficient or poor procedures and documentation, or missing procedures and documentation, out of date as well, as I previously mentioned. And a lack of supervision, if that is in fact required. We all need adult supervision from time to time. So like I said, don't be shy about getting someone to come and give you a bit of a wake up if that's needed, and check what's been going on. It's not a sign of weakness. I think it's a sign of strength that you've identified and acknowledged that you're a human and you have frailties. You're not saying you're not capable of the job. Maybe you're just a bit compromised that day. And, once you're in the air, it's too late to get someone else to have a look at the work you performed. Some error-producing conditions, and some are more powerful than the others. The number one there on the list, obviously, lack of familiarity with a task. Quite often, you really need to do the task a few times under supervision, get familiar with it, especially if it's something to do with flight controls or engine tasks, things like that. These are critical items that, if they fail, can have a very poor outcome. Time shortage is a classic. Everyone's short of time these days. They're all trying to jam more into less as they go through. Information overload, that can always come with a lack of familiarity with the task as well. These can all work related, and they can actually add together. Those risk factors can certainly spiral logarithmically. Poor feedback from the system. When you're checking a system, you're not getting the right feedback, or poor feedback, so you can't ascertain its serviceability. Inexperience kind of goes hand in hand with the first one there. And poor instructions or procedures. Again, we talked about that being out of date or incorrect. Someone just hasn't dreamed these up. We've pulled these out of reporting data, and they, as I'll say, I'll give you the reference to where all these came from as well, so you can have a look at them for yourselves. Red flags, we all get these red flags going through life, and the number one I think I would say to you, if it doesn't feel right, if it doesn't smell right, if it doesn't look right, then it's probably not right. So listen to your gut, and go back and start again if you need to, or get some help. As it took, you can see these relate to the previous one there, the error-producing conditions. It's a task you've never done before. If the procedures are a little confusing, interruptions occur partway through the task. Boy, aren't our lives full of interruptions these days? There's all sorts of devices getting around, vying for our time, our attention, I should say. Tools and equipment, spares unavailables, we talked previously. More time pressure involved than you're used to dealing with. Fatigue comes in there again. Working with unfamiliar people, and that goes for unfamiliar environments, unfamiliar machinery, all those sorts of things. So just be aware when something changes in an environment where you're used to things being a certain way, that's a red flag. So pay attention to that. So it comes under the whole change management banner. Like I said, if you feel uncomfortable or uneasy about a certain task, then time to put your hand up and say, nah, let's put the brakes on this, and we'll come at it from a different angle, get some experienced supervision or knowledge, get a second go at it from another angle. And look, other flags, what's yours? people have certain conditions that come on when they get into some sort of underconfident environment, and you need to identify what yours might be. So talk about it to yourself or others, and especially, if there's any form of interruption or distraction during the task, then that's a red flag for me. Some error probabilities, and as I said, these come out of these reports, so we'll talk about that in a minute, where you can find more information. These are estimated, but they derive from hard data, from accident reports, incident reports, and just routine reports as well. So just, for every 1,000 times you do a particular task, there's a probability that 2 times out of those 1,000 you might install them incorrectly, and it goes on down the list there. But what if you're feeling really fatigued and the procedure's not the right one, and you install the nuts and bolts incorrectly? You don't tighten them. They're the wrong orientation. They're incorrectly tightened, and then you lock wire them the wrong way. So these, as I said, these errors and probabilities can add up as they go. A really interesting one here for me is looking at the check for error in another person's work. 100 errors per 1,000 tasks. That one just jumps right out at me. Why is that so? How can that possibly be? Well, you think about it. When you go to check someone else's work, they've already done the work. We don't like to, pick and degrade other people. So you probably got an expectation that they know what they're doing. They've done the job right. But I think the opposite goes. You really need to go in with a fresh set of eyes. There wouldn't be a requirement for a second check if there wasn't some reason for it. And there is a really good reason for it, because it's generally on flight controls. And that's a no-brainer. You can't have any errors in flight controls, whether they're misrigged, reverse rigged, loose security, lack of locking, all those sorts of things. So if you take one thing away from today, please look at that one there, checking for error in other people's work. That's a huge jump in probabilities. So just be aware of that. And the other thing too, while I'm on checking someone else's work, is sometimes the people you're using aren't as experienced as you. They might need to be trained to how to go about that task. And just make sure you don't lead them down the garden path, to make the same errors that you might have made in there. Get them to look at it with a fresh set of eyes. So how do we go about mitigating these errors so that they don't occur? Well, we have processes in place for training. We have procedures in place. We have manuals. We have approved data. We use the right tooling. We don't use the cheapest tooling we can get, because that can damage us, the aeroplane, and the machinery associated with it. There's always paperwork to go and certify for, to say that the job is done. And that's a checklist, just like you would use when you go flying. It's a method of making sure that certain tasks that are called up have actually been carried out. This is a pretty striking picture, this one. This is evidence of where a procedure was not followed correctly. And they did a non-destructive test to ascertain whether this prop hub had a crack in it. The test they used was the incorrect one. And very shortly after the aircraft went back into service, this blade came apart in flight and resulted in some quite serious injuries to two people on board when the aircraft came down. So, there's some serious ramifications in undertaking aviation maintenance, and you really do need to make sure you're adequately prepared, set up, patient, and capable and confident to do the job. Just a close up there, you can see. So moving on to capturing those errors that might have made it past the mitigation stage, we have inspections. That's why we do the maintenance, to try and capture any errors that come through. So don't be afraid to go and do a second check of your own work. We have those independent inspections, as we talked about, and many organisations go above and beyond what's required in the regulations. They'll do duplicate inspections, as it's called in the RAOS world. They'll go and do inspections on any manner of systems in the aircraft to make sure, because it's critical system maintenance. And they don't just go with flight controls. Certification, as I said, when you put your name on the bit of paper that says this job's been done in accordance with the procedures, we use the correct parts and the tooling, and it's good to go. That's a method of capturing it. It's a mental check. Did I do it? Don't just sign it off. Did I do it? Yep. Okay. Then you go through the certification process. Functional testing. This is a really big one. If you needed to change an oil filter or a fuel filter or something on the engine to do with fluids, you would never do that and not do a leak check. That's a perfect error capture method to make sure that anything, you're going to make sure that first of all that the engine functions correctly, but then you're also going to check and make sure that it's not leaking. A couple of others here that aren't required in the CASA world anyway. It's when you might do you do need to do a post-instrument checks for leak checks and things like that, but you might do another one subsequent to changing something else. Maybe it's already signed off. Don't be shy about doing them repetitively, getting someone else to have a look. Some leaks don't become evident for quite some time, so you might come back and check it a bit later as well if you suspect maybe something's not quite right there. And also some tasks require a post-maintenance check flight. Then open the cowls up, take the cowls off, whatever it is, have a really good look around everything and make sure that it's all good there. Even if it's not required by the legislation, make sure you take the opportunity to capture any errors that might get through. Quick case study here. This is unfortunately it had a fatal outcome, but I'm just going to use it as an example to drive the point home. If anyone knows anyone that was involved with this, I apologise for that. But again, we're not laying blame. We just need to make sure we take the opportunity to learn these lessons, given that has already occurred and we can't do anything, but we can honour those people involved by making sure that we learn from those lessons. So unfortunately, there was a missing self-locking nut in the flight control system, the cyclic control system in a helicopter. And when that failed in flight, it resulted in in-flight breakup of the helicopter. And unfortunately, the pilot was fatally injured. There's an ATSB report here, and you can grab the number off there if you want to have a bit of a look at that. It goes into quite a bit of detail. But in the wreckage examination, they couldn't find the bolt that attached that flight control. It was missing. And as we know, if a bolt is correctly installed with a locking mechanism on it, it's very unlikely to just fall out. There might be a failure mode that they can detect if it actually failed in place. But and these things are generally double locked as well if they're safety critical. So there was processes in place after this rebuild of this helicopter to make sure that it had been correctly assembled, and then an independent, or as you guys call it, a duplicate inspection carried out to make sure that all of those critical items were connected. But unfortunately, somehow it got through all of those systems and resulted in the fatal outcome that we saw, the loss of the helicopter and the pilot. Very, very tragic. In some cases, there's design tolerances put in place to try and capture those errors. So you can't actually put the bolt in the wrong way, or the system is designed so you can't reverse the control cables and things like that. And in some aircraft, they have redundant and duplicated systems to try and make sure that if there is an error and it's not captured and it makes it to the flight line, then the flight can be safely carried out, completed. Some key points to that discussion, no matter how hard we try, we are never going to eliminate human error completely. So we need to recognise that it's a hazard, and we need to manage that. And we can do it by we can reduce it as much as possible and make sure that adequate systems are in place to capture those errors or tolerate those errors if they're not captured. And simply telling people not to make errors, that's not a sound strategy, because you're not going to change human nature. So you need to put things in place: training, education, supervision, independent inspections, duplicate inspections, and all those sorts of things. Stress. Who's not under stress? There wouldn't be too many people in this world. We've all got a workload, and there's always time pressure. Even if you're doing this in your own time on the weekend, I'm sure the family's on the phone saying, when are you coming home, that sort of thing. Distraction and interruption, that's a huge one for me. Through life and through my years as an aviation maintenance technician, many distractions, especially these days. Those mobile phones, not just ours, everyone else's around us, they are a real source of distraction. And interruption as well. we're in aviation. If an aircraft taxis past the hangar or the location that we're doing the maintenance, we can't help it. Our heads turn and we look at what it is and what that person is doing. So can we or should we accept interruptions and distractions during high-risk safety critical maintenance activities? I think not. And what can we do to mitigate that? So, some tasks are more critical, like I've talked about flight control maintenance and engine maintenance. They are really critical. That's not to say that there's other jobs that shouldn't be given that status, but some jobs are certainly more critical than others, and that's why they attract things like your duplicate inspection. So you just need to manage those ones a bit more carefully, and we'll give you some strategies to talk about that. We'll talk about some strategies for that to maybe manage that. As it says there, these tasks, unless carried out as authorised, can directly affect aircraft or personal safety, and we've seen an example of that in 2 cases in our case studies already. This is no joke. There's many workshops around the world. The US Air Force have some really good strategies in place to make sure that people are minimised with their distractions and interruptions. If sometimes it's just a matter of training those people around you who might interrupt you or things that might distract you. Try and minimise them as best you can, and sometimes just telling people that this is something that I need to divert my whole attention to. Please don't interrupt me. Don't minimise distractions. Shut the doors in the hangar. Whatever you might need to do to make sure that that you have that sort of sterile environment maintained to concentrate on the job at hand. What are the common things that distract you during your work? That's, it doesn't matter whether it's your day job or your weekend activities, whatever it might be. People coming in and out of the hangar, having a chat. Hey, Joe, how you going? Same when they exit that space. Phones ringing. Some people have more than one device and not many of them have them on silent. So there's lots of bing, bang, bongs going in club environments and hangars and things like that. So that's something that you can do to try and minimise that distraction and interruption. Like I said, aircraft taxiing past or taking off, vehicles in the vicinity, all those sorts of things can take our attention away and result in those interruptions or distractions from the job at hand. Identify those, and especially the ones that affect you personally. What would you do? There's a perfect opportunity if I could feel this one out to people, because everyone's got a different way of doing things. But, if you are interrupted or distracted during a task, recognise that and verbalise it even to yourself or those around you. Have an organisational procedure in place for that. It's a safety critical action that you're doing. Make sure that that is not compromised. You might have your own personal standards that go above those procedures that are advertised. Using documentation to monitor where you're up to in that task. Say, hang on a sec, got to make a note where I'm up to, then I'll talk to you. Using documentation for stages of maintenance, initialing tasks as you go. If you're in the middle of a task and there's no traceability for that, go back a few steps, 1, 2, 3, 4 steps, or to a known logical point, and then work through it again to regain that situational awareness of the task, or go back to an obvious point. You don't need to make this too hard. It's pretty straightforward stuff, but you just need to have a conscious method of doing that. Getting to the end here, as I said, there's some resources that I've pulled a lot of this information from. CASA's Safety Behaviours Human Factors Kit for Engineers. This is a really good kit, a lot of information in there. If you get hold of one, don't try and digest the whole thing all at once. But there's DVDs and resource guides. These kits are actually put together to run a course for a small group of people. But I'm here to tell you that thankfully this is actually available electronically on the internet through CASA. And if you just type into CASA's website there, the Human Factors Safety Behaviours Resource Kit or Human Factors Kit for Engineering on the CASA website, you'll be able to find that on our online store and order it up. Or you can actually have a look at that web link at the bottom there, and that'll take you off to where all those resources are sitting electronically available on our website. So feel free to make use of that. There's another really good resource that I've used any number of times, the ATSB's Overview of Human Factors in Aviation Maintenance. Don't take any notice of that great big jet engine. The probabilities of errors being committed by humans in big jet maintenance facilities are very similar to any other environment. They've hopefully got, well, I know they do have more mitigations and capture strategies and points in their procedures, but they're still just humans, and in many cases working in greatly complex systems with a whole lot of other people to distract them and interrupt them as well. So if you look at those examples, those resources, and they've got a different type of aircraft or a helicopter or whatever, don't pay a great deal of attention to that. Look at the learning that you can derive from looking at those reports, those incidents, those accidents, and that data to try and improve your own capability to make sure you don't make errors, or you capture them, or you put processes and procedures in place to mitigate the possibility of those causing an incident or an unintended outcome of doing that maintenance. Because at the end of the day, we're all trying to achieve exactly the same thing, which is safety in aviation, and we want to have confidence that when we do maintenance on aircraft that it's not going to turn around and give us a challenge that we might not be able to cope with. So that's all I've got for this evening. I know there was a fair bit in that, and that's why I've given you the suggestion there for those resources. I will just read before I throw to Cody and field some questions. In the ATSB's Human Factors in Maintenance report, there's a paragraph that I think bears repeating for anyone that's involved in maintenance. And the heading is Unique Factors, Unique Human Factors Issues in Aviation Maintenance. Maintenance personnel are confronted with a set of human factors unique within aviation. Maintenance technicians work in an environment that is more hazardous than most other jobs in the labour force. The work may be carried out at heights, in confined spaces, in numbing cold and sweltering heat. The work can be physically strenuous, yet it requires clerical skills and attention to detail. Maintenance technicians commonly spend more time preparing for a task than actually carrying it out. And dealing with document is a key activity that can take a whole lot of time up as well. So I think that that really bears a great deal of focus to the activities that aviation maintenance technicians undertake. It can be very challenging technically and physically, and maintaining that level of concentration. That's it for me, Cody. I'll throw it back to you to see if we have any questions. Okay, so I see a question come up there from Paul. What can maintainers do if the data available is not detailed enough to safely complete the task? Well, number one is to basically stop the task, go and get some advice, whether you do that through RAOs or excuse me, or through the manufacturer. You need to pull all the stops out to find that data. In some instances, data might not be available if the manufacturer has gone out of business. I'm not exactly sure what the RAO's process for doing that is, but in the CASA world, you'd have to get a design engineer to draw up a process that would meet that requirement to make sure that this task can be safely completed.
Thank you very much, Peter. And that's all the questions that we've got this evening. But thank you very much for your presentation. I think it's really important to reflect on the fact that we often refer to human factors for pilots, but it's just as important that we focus on human factors for our maintainers who are out in the field and maintaining our aircraft as well. But just touching on a couple of points from your presentation there, that's relevant to our members, and all of it's relevant to our members, but ensuring that you have a valid authorization that's particularly important. And obviously for our L2s, ensuring that you refer to any limitations that apply to your authority, and that you adhere to any renewal requirements on that authority, which for most L2s is 2 yearly renewal process on that. And obviously reporting is very important. At REOS, we have our online reporting system for defects, hazards, incidents, accidents, and you can even go on there to lodge a confidential complaint, and that can be done online from reporting.reos.com.au. That also fulfills your requirements under the TSI Act for reporting through to the ATSB. So please do take note of that and put those reports in. The more information and data and correlations that we can make from our end, certainly the more that we can do to identify trends and educate members. And obviously also, as Peter mentioned, the importance of actually completing your paperwork once you've completed those maintenance tasks. It's a common thing that we see out in the field, that maintenance may be done to a high standard, but the paperwork is letting people down. So please ensure that your maintenance logbooks are completed and up to date, remembering that that is also a log for that aircraft and will assist in the future with any sale process for a new owner if that is the case. And finally, if you do have any technical related questions, obviously don't hesitate to reach out to our airworthiness and maintenance team, which you can do so by emailing tech@reos.com.au. But once again, thank you very much, Peter, for joining us this evening, and thank you to CASA for the support.
Thank you very much for the opportunity.
Thank you very much. And finally, next week we have a live stream on Wednesday evening again at the same time. Next week we're talking to Mike Hutchinson on safety management systems. Now this will be aimed more at flight training schools and instructors, but please get involved in that. And also don't forget to go to the REOS website every week throughout October, review our National Safety Month content that we've got online, and complete those quizzes to go in the draw to win the multiple prize packs and the $10,000 worth of prizes that we've got available across the month of October. Thank you for joining in tonight. And finally, thank you very much again to our sponsors of National Safety Month, who have been able to make all of this happen for us and have been able to put the fantastic prize packs together that we have.